Alrighty, here's the video submission for Lab 4, wherein we are to use analog inputs and read values, analog values, in order to create digital outputs. Underneath this is a photoresistor, and as you can see, the motor's got a shaded area and an open area. So a variable amount of light is getting through to the resistor, varying the voltage that passes through the resistor, because the resistance is variable, right? So our analog sensing pin here is going to get a range of signals and cause, through our code, it's going to cause this LED to either turn on or off. As we can see here, I've got the voltmeter rigged up, and we can see that the voltage is in fact fluctuating between about 220 volts and 215 volts, 2.5 and 2.2, I should say. And the Arduino actually refreshes quite a bit faster than the voltmeter, but even with that we can see that, okay, there is a variable voltage coming across this resistor. So let's take a look at our code and explain why things are happening the way they're happening. Let me pull up the code here, hopefully first one. All right, so here down here is the Arduino's analog reading of the voltage, and there's a conversion, like it's not reading 600 something volts. If I slow this down, we can take a look. We can see that the voltage, and again there's a conversion, so this doesn't represent 500 volts, but we can see it, but we can see it values range between about 545 at the low end, and at the high end about 615. So the way we use that information to create a digital output for the light blinking, we first obviously set our integers for the motor. It's going to be at pin 6, and our LED is going to be at pin 12, and we set the motor to be an output and the LED to be an output as well. And then we begin with our whatever 9600 baud refresh rate. Anyway, so when we come here, we need to create a variable that we named analog input of the analog reading at pin A1, which is reading the voltage across that photoresistor. I also did a thing here, so I used a pulse width modulation, which is a digital to analog sort of conversion for the motor, so that it wouldn't spin quite so fast. If I change this value to, say, 40 and upload, we can see that it's going to be spinning quite a bit faster. And we need to give it a little touch, but we see it's moving faster. So that's the duty cycle. Again, it's not 40, doesn't represent 40%, but basically that's what the higher this value is, up to 255, I believe, is 100%. So there's a conversion ratio, but basically, in long story short, the higher this is, the faster this is going to spin. So anyway, so we got that. We got our motor kind of set at a slower speed than normal. Normally it should be spinning like a helicopter, just spin off the base there. So we got to slow it down, and it would probably spin faster than the refresh rate of the Arduino. So we slowed it down. So once we got that slowed down, we want to take an analog reading of pin A1, and we wanted to print it down here so that we knew what values we had to work with. And like I say, we ended up with values ranging between 615 at the high end and about 540 at the low end, right? So we want the light to blink with the variable voltage reading. So we set up an if command, or an if loop. So if our variable analog input is less than or greater than, less than or equal to 610, which doesn't represent 610 volts, but that's the Arduino's representation of whatever that voltage is, about 2.2, right, is what we said. We want the LED to turn on, to go high. And when that value is below 610, we want it to go low. And so basically, you know, as we see here, all these numbers, 610, above 610, it's about there, it remains high, and then all these values below 610, from there to about there, it goes low. And that's basically, long story short, what we got going on here. So, alrighty, thank you.